Welcome everyone to another Friday afternoon webinar with NORA. It's 2 o'clock Friday, and every Friday we have presentations from researchers and innovation presentation about artificial intelligence, machine learning, and robotics. So today we have Anne Håkansson here. She is a professor in computer science with a focus on artificial intelligence at UiT, the Arctic University of Norway. She is also professor too at NTNU, Trondheim, Norway, and docent in computer science at KTH, Royal Institute of Technology, Sweden. Anne Håkansson is the chair of Computational Analytics and Intelligence Research Group at UiT, Tromsø, which includes several different groups at UiT, Norway. Also, I just learned on that you're working in the Gender Balance Project at NTNU Trondheim, Norway, which is something that we all should engage in. You will surely also see more from NORA on the gender balance issue. Anne is also working at the KTH Live in Lab project in Stockholm. She is an author and co-author of several books, proceedings, and international publications, and serves in technical program committees of international top conferences, and also in the program committee of NORA's yearly conference. She's a frequently engaged speaker for artificial intelligence and popular science, and has been an ambassador for Uppsala municipality in Sweden. Today's talk, Anna, is titled AI in Cyber Physical Systems. When can fully autonomous cyber physical systems in society be achieved? So I'm really looking forward to your talk, Anna. Please, the screen is yours.
Thank you, Klaus, so much for this great presentation. I'm happy to be here and be a part of NORA today and tell a little bit of what I'm doing and what I foresee in the future, and what we should expect when we talk about cyber physical systems, and if we can really fully accept fully autonomous cyber physical systems in the society. And when can this be achieved? So that is what I was going to talk about today. Okay, you heard and you got a very nice presentation of me already, so I won't go into that. But I would like to add that I've been working in AI since 1993. I've been doing research since 1993. And that is a long time in our area. And what I started off with was reasoning strategies. And as soon as I say reasoning strategies, nobody really knows what I'm talking about. But it is about decision making and decision support in different systems. And we have that everywhere. And we get the data in, and we need to figure out how we can reason with this system or this data to get a valid and good result. So that is how I started off, and that is still very highly interesting today. Another thing I was doing very early was I worked with visualization and graphic representation, which is again very, very important in our area to understand what's going on with the data and the system and how the system is working. However, from that, I've been in many areas, started off with knowledge-based system and expert systems, but then moved into multi-agent systems and now cyber physical systems. So that is what I'm going to talk about today, what it is and what we can expect from them, what we already have also, of course, in the society, because we have a lot already. But what does it mean for us that are living with these cyber physical systems? Another thing, as you heard Klaus tell about, is the CHI group. And I would like to just mention this, that is one of the AI groups at IFI, the university in Tromsø. And feel free to look at the website and see more what we are working with. But we do work with visualization. Oh, I'm so sorry. Visualization and exploration of large data sets. We work with multimodal sensor network systems. We work with efficient AI for cyber physical systems and detection of complex patterns in multidimensional spatial and temporal data. So we are a rather big group and with a diverse a number of areas, and we are always interested to look at what we can do more and with collaboration with you. So please have a look and see if you find something interesting there. So the topic today is about, can fully autonomous cyber-physical system in society be achieved? Or more is the question, when can it be achieved? And the question is, can we fully trust fully autonomous cyber-physical system? And that means if they are fully autonomous, we don't steer these systems. They are fully autonomous in every sense. So they are working themselves without any intervention or any inference of anyone. So that means that they should be able to handle everything themselves. But that means that we are externally from these systems. We are people that want to collaborate with them, even they are fully autonomous. We would like to be a part of the society where these are moving and driving and flying and so on. So we are pedestrians, but we also maybe are external vehicles, but we also traffic signs, because the fully autonomous cyber-physical system had to work with the traffic signs. And for instance, we have 2 traffic signs here, and you probably know them already. But what does that mean for a fully autonomous cyber-physical system? And how will they handle these different signs? How can they handle them? And how would we communicate with these systems when they handle these signs? So before going into everything, what we can trust and what we can believe in, I would like to mention what a cyber-physical system is. So it is something that can often move around in an environment. It is a tightly connection of physical components, so it's parts that we can find in the environment. But there are also computer systems with algorithms that can do something with these physical components. So we have actuators to make them move around, or they can control or change their behavior. So that's a very important part in these cyber-physical systems. Yet another thing that is extremely important is that we have networks that we can connect the physical parts with the computer parts. And we use something called feedback systems. So we get a signal into the system, we make some decisions, and we send our decision back, and we make the sensors act accordingly, or the actuators to act accordingly. So we make these cyber-physical systems to handle the environment as we would like them to do, from a kind of settings we have, what we have decided, how we want them to behave, and then we make them behave accordingly to that. So it is an integration of different systems and different physical elements. And there are some that talk about the 3 C's, and that is communicating, controlling, and computing. And these must be in the system to be able to call them cyber-physical systems. Many says, well, there are no difference between a smart Internet of Things and a cyber-physical system. And then I say, if you can call a car, like a Tesla car, an Internet of Things, well, then it's maybe not that different. But in my world, the cyber-physical system is different, because it's a connection of many computers, many physical parts, and you steer it to a particular behavior. So usually when we talk about the cyber-physical system, we have small parts, but we also have big things. So the small one, I talk about grids or small mobile systems that we can carry around. But the big ones are airplanes, or we talk about avionics, where we can move the airplanes in the air. But we also talk about control system, which we have in industries, and robotics and so on. And what we do expect from this system is that they can cooperate. We can cooperate in traffic when it comes to air, car, water, and other traffic. But we can also work with the industry where we have several cyber-physical systems working together to carry out tasks. Another thing that's been very popular lately is the healthcare. We have many people that are connected nowadays to machines to monitor them and to support them in different ways. So we try to monitor people and we try to control different devices so they will feel better and live better. Like, for instance, in the heart, you can have now a part which can actually start the heart if it's stopping and so on. So there are many things that nowadays can work together with the humans. Another thing is that we can have cyber-physical system operating together in dangerous and in inaccessible environments. So if something happens, we can use cyber-physical systems. There are no humans involved there. So we can get them to work for us and rescue people. We also talk about distributed cyber-physical system, and that is what we can find in, for instance, industries, where we have several different cyber-physical systems working together to carry out tasks. And the last one I want to mention is the efficient smart cyber-physical system, which have a really heavy decision-making and negotiation between them, so they can negotiate and see who will carry out the task and in which order and so on. So they are cooperating with each other. And the last one is the one I will focus on today. So let us look at one example of a cyber-physical system and the data we can get. Well, we have a lot of cameras. I just take Tesla as an example, but there are many different self-driving cars. But if we look at Tesla, we have 8 cameras that are capturing a lot of data going around the car. We can have a long range, as you can see on the picture all the way up to the right. You can see we have about 250 meters for some cameras, but also around 50 for other cameras, like the rear camera. So depending on what we want to use it for, we have different range for the cameras. But these are collecting data and they make the car to work with the environment according to what it gets for data. It also have a radar and it has sensors, which is ultrasonic, and it has a so-called supercomputer according to Tesla, but it is a computer which you have like an iPad in the middle where you can change the settings of the car very easily. So those are the hardware there. And then you have the software, which is processing all the data all the time. And you have a neural network that actually trains with when the car is driving. So you train the particular car, but you also can announce the other cars about the environment where you are within. So other cars can actually drive better when they come to the same positions that you have been at. So you actually learn from each other. And also it has an Ethernet connection as a network. So it has everything it needs to be a cyber-physical system. And I also wanted to give you an idea of what is important and what we can foresee. If you look down to the right, there is the traffic here. And here we have a lot of cars moving around in this traffic. And they need to not only be aware of each other, but also they need to drive in a smooth and efficient way. So they need to decide how to move in this environment to make it efficient. And I usually call that a volatile, distributed, smart, multi-cyber-physical system environment, where you have only the ones that are close to you are the important cyber-physical systems. Not all that are around the world is important, only the ones you have to confront for the moment are the ones that are important to you. Therefore, the name volatile. So, decision-making in cyber-physical system, and this is also the incentive for my research, which we talk about reasoning strategies, but that is different strategies to do the decision-making. And if we look at this cyber-physical system, we find two different categories. We have the autonomous cyber-physical systems, and we have something called closed-loop human-machine systems. And if we look at these, we can see that it doesn't matter which one we are working with. Both autonomous cyber-physical system has decision-making that are operating independently, but also the closed-loop human-machine systems have decision-making, even though they have it in more real time, or should we say near real time when we come to computer scientists, because they never feel that we have real time in our systems. But they are working with decisions. And this is something we need to work with, because if we will have cyber-physical system in traffic, they need to make fast and valid decisions, but they also in a near real time as possible. So let us now go back to my talk. I gave you an idea of what the cyber-physical system is and where we can find them. But how fully autonomous are they, or how autonomous are cyber-physical systems? And what is needed and what must be done before we can accept them in our cities and societies as fully autonomous? Well, there are categories of autonomous driving. So we have from the 0 level to the 5th level. There are 6 different levels. And if we look at the one that is 0, there is no automation. And if we look at the level 5, it's full automation. So from the beginning, it's only the driver who has all the charge over the driving, whereas in the 5th level, the human driver is not even near the system and cannot be anything but a passenger. So the only is what is happening is that the system has full control of everything. So if we look at the level 5, and I would say that we don't have any system currently that is fully autonomous. It is highly autonomous. And here we mean that we have a driver who is a passenger at some time, but also can interfere when it's needed. So if something goes wrong, the driver can actually go in and support the car. And I would say that most of the cars we find today, it's here on level 4. So they are semi-autonomous in that sense that they are not fully autonomous, they are highly autonomous. So there are different levels of this, and you can probably find that there is no car nowadays that have no charge at all. So most of them can park themselves, or they can at least tell you or stop the car when you're coming close to another car and so on. So almost every car today has some automation included. So, but if we now don't have full autonomous systems, what should be done to make them full autonomous? Well, we need to have systems that can adapt themselves to the environment at every situation we have at hand. Can be no situation at all when we can't get the car to adapt to this environment. And we need to have a complex decision making so we can adjust the car to, or the cyber-physical system's behavior, so we can trust the cyber-physical system. So we have a trustworthy autonomous decision making. So that means that we need to have data in that we can make a valid decision on, so we can also adjust the behavior accordingly to what we have at hand, the situation and the environment. The cars need to have a self-management and self-control. And as you know, if you have a fully autonomous cyber-physical system, they usually use battery and they need to be charged, which makes it interfere with the environment. So you need to stop and know when to stop and where to go. So you need to have a plan for these systems, and they need to manage those plans themselves. And they need to control themselves so they can work according to the plan. They must be able to self-optimize, especially if they're going to drive in traffic. We don't want them to go around each other. We want them to really go where they are expected to go and so on. And they need to be able to self-mend or at least self-heal. So if something goes wrong, a system goes down, how could they handle that? And how would they handle, for instance, if a camera stops working, what will happen then? Or if they lose the internet connection, what will happen then? So there are things like these that I think must be done in these systems to be able to trust them, fully trust them. What is more needed in our society and cities is that we must have data-intensive environments that are smart. So the signs can tell what it means with be aware of something, like I showed you the signs, the traffic signs. But we also need to have other cars that are communicating with each other in as near real time as possible. And this requires a fifth generation where we can have data fast transferred from one to another. And we can also spread it out to many different devices. We probably will have a lot of big data going on. So we need to have systems that can handle big data and process big data. We also want to have humans' preferences in the car because we are the ones who are going to be the passengers in the car. So we need at least to tell the car what we want and what we expect from the car. And our preferences are different. So some wants to go fast and some wants to go slow and so on. So the human preferences are important. We also need some kind of a push and pull technology so we can pull information from the environment, but we can also push information to the environment. So we need to have a technology that can both pull and push. And if we can get this, in my mind, I think we can have a trustworthy system, but it must be robust. So we need to make sure that it has a robust reasoning with the data it got. We don't have any information about how much data the car has or the cyber-physical system has. We don't know how valid it is. We don't know how incomplete or contradictory the data can be. It can actually be the case that you can say, get a cyber-physical system that says go left, at the same time it says go right. So which one would it then take? So we need to have decision-making that can be robust in a sense that we can get the right order of the decisions and also valid decisions. So we need to have an outcome that is acceptable. Negotiation between the external parties is utterly important. We are pedestrians and we need to communicate as well, which means we need to have a device as well that can communicate with the cyber-physical system. Or we need to have a cyber-physical system that easily can pick up pedestrians and what they intend to do, so we can stop the systems fast. Another thing is predictions. Predicting what's going to happen next is important. So we need to have prediction for the planning, but also for services and so on. And all of these must be secured. So we can expect we have environments that are distributed, connected and coordinated. And it's highly heterogeneous because we have so many different cyber-physical systems running around at the same time. We need to make sure that the time temporarily is the same. And we know also that the spatially that we are on the same spot, because the time here between the systems is important, so we know where they are. So we need to have latency sensitive systems. We don't want to have latency that are not acceptable. So that are things that we need to work with. Another thing is that we need to have adaptable and scalable systems. Robust, I already told you about, but the cyber-physical system needs to be responsive and resilient, so we can always trust where they are, what they are doing, what they are planning, and so on. So we need to get a safe and secure environment. And I usually talk about usable and reusable parts that we can use in the environment, so we don't invent the same thing over and over again. So what am I doing here then? Well, I'm dealing with this quantity of data and quality of data. And we apply different reasoning strategies. And you probably know all about the different strategies already. The deductive, inductive, abductive, case-based reasoning, non-monotonic, non-monotonic, and so on and so forth. But what we do is that we try to figure out which one is the best for which situation. We don't use the same over and over again. We also have analysis with different machine learning algorithms. And we also use neural networks, of course, not only deep learning, but also artificial neural networks. And we need to figure out when we can use the different networks and when we should apply them. Because as you know, near, or I should say real time, is not easy when it comes to neural networks. And another also that maybe not be too familiar to you is the stream reasoning. And stream reasoning is when you pick a part of a video and you work with that part to reason with the content. So you go with the several frames and you can work with those frames to learn from environment. So you can actually have settings in the environment for a particular traffic light or traffic sign, and we can just pick up pieces where we can learn from how people have behaved from that, and maybe also improve the environment for the cyber-physical systems. We have to have negotiation between the parts, and as I said, they are highly heterogeneous because we have different brands, we have different models, and we need to have them synchronized so they can deal with each other, deal with the task, and deal with the deadlocks and so on. Because we as humans can run into deadlocks, but so can the cyber-physical systems. Well, I hope I gave you an idea of what we can do in the society, what the cyber-physical systems are, what we expect as problems, and how we need to work with these problems to fully trust fully autonomous system. So, thank you for me.
Thank you very much, Anna, for a very exciting talk. So please, everyone, now Anna is open for questions. So please use the Q&A or the chat to post your questions. I can start on. In Norway, we have a very high degree of electrification and electric cars, and it was even in Super Bowl in the US, Norwegian electrification got quite some attention. So do you find that we are now so in the forefront in Norway in this field? Do you think we should? It's maybe you're maybe the wrong person to ask this because you will surely say yes. But should we have more research, more resources going into this also from the application side, from the AI side?
Oh, absolutely. Yes. Of course.
That was pretty much as expected. A very dumb question from me.
So, but if you look at it and all the perspective that I try to give you, it is actually a lot of things going on in these cyber-physical systems. And we need them to collaborate in a smooth way. So we need to have a lot of research. I only, if I say only, look at the reasoning behind what they are doing. But if you look at the safety way and handling the traffic signs or handling the different heterogeneous devices we will find there are so many things that we need jointly to do together. And it will take years to solve it. So yes, I think we can do it in almost any direction that I gave you during this speech. So yes, I think so.
Absolutely, and of course you are in this field. Who are you collaborating with in Norway? Do we have many groups working at this?
Yes, we actually have, I shouldn't say many groups, but we have a couple of groups that are working together. So we have in Tromsø, Narvik, and NTNU in Trondheim right now. And we are also trying to apply for money with one of the NTNU postdocs. So we try to get more people in. So, and we are open for collaboration. So if there is anyone that wants to join us and is interested to work with this, so just send me an email, because we need as many as we can, and we try to get help in every sense. But as I said, there are so many things, and it's really hard to work with only one thing. It's like a united part that we need to work with, and these need to collaborate also, each and every different applications. So yeah.
Extremely complicated and many parts, as you say. We have some questions here, so I will read them up. First from Silvina from Argentina. I have a question for when you deem appropriate. If we are, say, in L4 now, what could have gone wrong with the Tesla unit that crashed into another car and kept driving with a dead driver inside until it was stopped by an obstacle? Was it a driver's failure to over-rely on the car's abilities?
Okay, I exactly don't know what happened with that particular situation. So
it also says that the driver actually watched the movie when he was crashing. So yeah.
Yes. The thing is with the self-driving cars right now is that there are many things that can go wrong. So for instance, if you have a self-driving mode on, it drives with the lines on the road. And if it loses those lines, it starts to wobble. It actually should turn off the system, and it should make the driver to start to drive the car. So it could be something with that it was still driving by itself, maybe driving into somebody else, because this can be for quite a while ago, because they didn't have that facility that it went out of the mode of self-driving. So it's just continued to drive. Another thing is that I don't know about the camera in front of the car, but it is supposed to stop. But we saw I think it was Volvo self-driving car. It should brake, hit the brakes. It didn't. It was just running directly into the truck. So with that said, there are no self-driving cars that can be trustworthy. So you can't drive them without keeping your eyes on the road. That's the problem. You cannot fully trust them, even though they are driving on the level 4. You still need to be the driver here.
Absolutely, but this is the goal, right? So could you look into the crystal ball? How far are we actually from totally L5 then self-driving cars?
Oh, I would say that we are quite a ways years, I would say, actually, because first of all, as I mentioned, we need to have this 5-generation network and communication, because I think we need to cover bigger areas and faster data via the vehicles. So that is one thing. And now we have, as I said, half self-driving cars. And there are many manufacturers who actually promote this as self-driving. But we still need to be there and be a part of it. So we have that step to take first. And then the last step of every situation, which means that we need to encounter every situation. And that will take a long time to figure out all the situations we can get.
Yeah, absolutely. Do you think, because in kind of more easy environments, the cars work quite well, would it be a direction to go to kind of reserve some areas, some distances for self-driving bus, some kind of more easily drivable distances, or is this considered in Norway? Do you know that, or are we just waiting for kind of a more general self-driving autonomous car to tackle every kind of aspects of self-driving?
We do have self-driving buses already that are fully self-driving, but they go like 5 kilometers per hour. So they are very, very, very slow. And they don't have the plan of going to any battery charge station or so. So we don't have that really. We do have prototypes, but we don't really want to let them loose on our roads yet. And another thing is that if we look at the infrastructure, it's not there either. So we don't have the infrastructure for the totally self-driving or fully autonomous cyber-physical systems yet. So there.
But do you think, my question is more, do you think we should maybe should we prepare for this? For example, in Tromsø, it would be a very challenging environment, I guess, with a lot of snow and a lot of maybe poorly marked roads somewhere, places. And should we start preparing for this now? Because this thing, the infrastructure takes time to build.
Yes, I think we should prepare for that, because now we talk about cars, but that is only one of the cyber-physical system that we have. We have the drones, and they are self-driving, many of them. And I know for a fact that Google they want to deliver packages solely by robotics, using robotics, so robots moving around. So if we want to create a smart system or society with the environment that works with the smart systems, I think we should start doing that. So roll out 5G, but also think about what is needed in the environment to make the devices understand what is the road and what's not. So we can maybe, I mean, there were something called like elk poles, which was actually a way to find and see animals between poles that they had along the roads. And I think something similar for the self-driving vehicles is also important, because we don't want to have the drones flying over our heads, for instance, and so on. So we also want like a lane for them, I guess.
Exactly. Yeah. So we need some regulation and some preparation for that, I guess. Another question from Ronald Hartung. Dealing with the sync of the data in a CPS, have you considered biological models?
No, I have not yet, but it's highly interesting to do that. So we can learn a lot from the nature and using biology and biological AI systems. So I think that working with that would be very interesting. But I would emphasize that sync of data is utterly important, especially if we're working with several cyber-physical systems that are working together. We need to know the position where they are. We need to know what they are doing. We need to know their plans. We need to know where they are at right now, and syncing the data not only in the vehicles but also between the vehicles is utterly important.
Absolutely.
And handle the time frames there is something that I've been looking at, but I wouldn't say that I use biology or biological models for that.
And Ronald, if you have a following up question of what kind of biological systems you're thinking about, please write it in. Next question is from Arno Gottlieb. Trustworthy AI receives a lot of interest and attention in EU these days. If you are aware of the work of the high-level group of AI experts, how do you see in particular the 7 requirements of trustworthy AI that have been defined there? Part of the EU strategy on AI?
Well, I know well about the high-level group, and I know about I would call them European AI experts. I don't really see in the 7 requirements of the trustworthiness, so I can't really say exactly what it is. But I know it's been discussed in many situations, and trustworthiness and ethics, and that's the thing I can think about right now. But they are very, very important. And also I know of the US group that are also working with the ethics and how they don't want AI to destroy for people, and they want us to have ethic rules and so on. So it's a lot going on there, and I know also they want to start this bureau of ethics. So that's the only thing I can think about right now. But yeah. So that is what I can say.
Exactly. Should also be mentioned that also Norwegian AI strategy is highly inspired by this high-level expert group and their strategy. So I'm sure Alex here can also add to this. Alex from NORA has also this as a special topic for himself. So
yeah.
He knows a lot. Can you say I mean, also one of the trustworthiness issues is robustness, and you touched upon this in your talk. I mean, all these systems, to be reliable and to be trustworthy, they need to be robust. How do you see? One thing is kind of the robustness in the car or the vehicle itself, but also you can find the adversarial serial attacks. I mean, you could change some small things on a traffic sign, for example, that could make the car interpret it differently, although it looks quite similar to us humans. So how do you see upon what do you think about this field of research?
Yeah, it must be done a lot. And every time we do something that we are connected to the network, we open up for vulnerabilities, and we make them systems and the devices vulnerable for attacks and changes that we don't want to. But it can also be mistakes. You do mistakes. We are humans and we make mistakes. So it doesn't have to be a hacker, or it doesn't have to be something you want to destroy, but you destroy it just because you didn't know better. And one of the things we are actually working with our group is robustness. So we have robust decision making, and we have robustness analysis. So we are working with that, and we try to capture the data, look at the data, try to figure out what kind of data can be missed and how much can be skewed and how much can be in contradiction to each other, but still work well. So there is, where is the limit for where we can still trust the system to do right thing, even though there is a traffic light not working, or so there must be still mistakes, I think, in the environment, and the cyber physical system must still work with it. So I guess that we need to have a combination of things, both internally in the system, but also externally in the environment.
But should we tolerate mistakes also from the systems, from the self-driving cars? I mean, you will surely have mistakes, almost even in almost perfect world.
Yes.
How should we handle that?
Oh gosh, you have good questions here.
Hard questions.
Yes, absolutely. Unfortunately, I remember I read an article 2 years ago. It says that this is the year when we will see a lot of deer that will be hit by self-driving cars. And that is, I feel that is where we are. We will still see mistakes, but we don't want to have mistakes in the cities where we have a lot of people. And I mean, there are people without thinking maybe just run out in the street because they think they are right walking over the crosswalk, which they are, but the cyber-physical system may not pick that up. So they may not stop, and that would be absolutely dangerous. So I would say that if we should really be able to trust the systems, we cannot trust too many mistakes from them. And also because if we start to trust too many that we don't, we understand that we can't trust them, then we will create a system or environment that we don't want to live in. So that will stop the development of these systems, is my guess. So we can't have too many mistakes.
No, and that's the hard thing, I guess, because let's say that you develop a system that will do only half the mistakes that a human does. So it will maybe save half the lives from traffic accidents. But it will still make mistakes. So how should we as a society proceed? And should we then allow for, or maybe even not only allow, but like Elon Musk is talking about that it will be not allowed to drive yourself when the autonomous system is better than humans. How should you approach this, and what kind of what do you have any thoughts on what the level should be of accepting mistakes from an autonomous system?
Yeah. First of all, I would say that sometimes if you look at the elderly, maybe it's better to have a cyber-physical system driving instead of the elderly, especially thinking my old father is 87 and I don't know about his sights and so on. So maybe a cyber-physical system is better in that sense. But I think that maybe we should be able to trust the drivers that still be able to override in some cases. When you see, if you are a passenger, if you can still say, hey, this is going wrong, and just hit the brake, just something like that could be still accepted, even though they're fully autonomous, I would say. So that is one thing. Having a GPS that always is going to tell where the system is, and always have a system that always steers the system, the cyber-physical systems, that is external systems, computers that are steering the cyber-physical systems, can be dangerous because you let many people in. And we don't know where that will end. So this is a very tricky question, actually. So it's really hard to answer. But there are other things you can actually do. Say, for instance, that if you have a traffic light that is maybe changing from until red really fast, they can signalize to the system that you need to stop now directly. And if that is in a millisecond or less than a millisecond, then you can actually get it to stop. Another thing is that you can actually build trap into the environment that you don't think about, but you can do. So you can actually trap the system if something goes wrong, if it goes ballistic, sort of. So you can trap it and you can actually get the wheels to slow down and so on. So we have those traps, for instance. I've seen those there. They are actually moving down. They have like a brick in the lane, and when something goes too fast, it moves down, so they stop the car and so on. I mean, we can build things like that in our environment, but maybe we need to do some of that. So it works well.
Absolutely. And I think it's also pretty clear that humans don't tolerate the same level of mistakes from a machine, actually, as from a human. you see this also, for example, discrimination. Many systems have been trained on data, and in the data you have discrimination. And of course, the system will then continue this discrimination. And then this gets a lot of attention, which is really good. But it also shows something more, because it shows that the data, that the human behavior before the system actually was discriminating. And as such, also the tool could probably be used positively in a way, because now we don't accept it when the tool kind of rolls out. And in some way, it's often also easier to change AI system than to change kind of the more distributed discrimination among humans. And this is, I think this touches also upon this question of accepting kind of mistakes from self-driving cars. Should we, when the cars are better than humans, should we then accept accept mistakes, or should we wait until it's almost perfect? So I think that will be a hard question to decide in the future.
Yes, I think so, but we already have them, and they have already made a lot of mistakes. So they are already there with the beta versions and so on. So we have already allowed them into our society. But the question is, when can we fully trust and fully accept the fully autonomous cyber-physical systems? That is another question. And about the unfortunately way of mistreating people, if I would say that, where we have data and we don't think about what we are training, so we exclude people. That is, in my mind, an ethical problem. At the same time, should you allow a child as a passenger, the only passenger in a car? Is a question. Would you allow a small boy or girl sitting behind the wheel, or not even a wheel, because there aren't going to be a wheel, but are you going to allow a child to be alone driving? And I don't know. This is
it's a hard question. I have 4 kids, and my job these days is being a taxi driver back and forth from wrestling and exercise and gymnastics and soccer and whatever. So I have no doubt I would allow them if the car. No, but these are very hard questions, and it's very interesting topic. So it will be exciting. Not only the technological aspects of this, but the societal aspects are so interesting.
And another thing, what kind of driving license will you have for the vehicle, for the drone, for the car, for the boat, for the airplane? Will you still be a pilot, or do you want to accept anyone?
And who's responsible? I mean, for a fully autonomous vehicle, it should be, of course, the one producing the vehicle, but still, then who would let them out being fully autonomous if you kind of is responsible for every mistake? So you will have a lot of these very hard questions. If anyone have more questions, please post them now. And if not, I think we will just call it a day. It's an extremely interesting topic, and as I said, not only technological, but also all the ethical aspects and everything that we also have touched upon now. So thank you so much, Anna, for a great talk.
Yes, thank you so much for having me here today. It was great to be able to reach out to you. And if somebody wants to talk about this or be a participant in a collaboration, so send an email to me. It's my name, so anne.håkansson@uit.no. So I can maybe write it.
Write
so you
it
have
in
that.
the chat so that everyone has it.
So and we have a lot of things going on, so it would be very, very nice to have a collaboration with the people out there. So please contact me. So thank you.
Thank you again. Bye everyone. Have a nice Friday and a nice weekend.